Hi there, guys. So I just want to take this opportunity to talk about boat wiring a bit. So basically your 12-volt system in your boat, and more so for smaller boats with like highly sensitive and important equipment. So basically, with a small boat, invariably you've only got one battery, and so that battery is directly plumbed into your marine electronics, and it also is your start, your cranking battery for your motor, as well as for your trim and tilt. So there's on a normal system, there's like no filter between those quite abrupt fluctuations in your battery and your marine electronics. So basically when you crank an outboard, the voltage can drop right down to like 10 volts. Most of the new fish finders or plotter combos these days can handle that big fluctuation. So my concern is how healthy is that fluctuation for the electronics. So you'll notice that if you've got a really old battery that's been on the boat for years, and it's getting a little bit weak, and it's not holding the energy as well as a new battery would, you might find that your marine electronics might drop out when you crank the motor. So what I've installed is what we call a Victron DC-DC converter. Now, I've got no affiliation to Victron or anything like that. I do install them on my boats if the customer wants them, but my thing is these things really work incredibly well as a buffer between the charging process and the cranking and all the other motor requirements of the battery. It keeps the marine electronics separate from. So my installation, I've got as you might know, I've got the Furuno TZ Touch XL13, and I've got a base mount ICOM VHF radio. That's it. There's nothing more than that. I do run a side scan transducer and a normal 5200 transducer. So basically I'll show you my setup. So basically inside there you can see there's the DC-DC converter. You get various sizes. That's a 9 amp, which is more than enough for my system. And I've got the Blue Sea Systems positive buzz bar there with the built-in fuse and a couple of spare fuses, switch panel, etc. So basically that DC-DC converter, what it does is it will only output a preset voltage. So it comes standard at 12.2 volts. I do find that can be a little low because you'll lose efficiency through your switches. So all switches have a different sort of contact resistance. So I tweak the DC converter up a little bit so that we've got a good solid supply into the machine. So you can see here, you can see there I've got 12.35 volts or 12.3 volts supplied onto the machine. So that basically that never changes. So when my motor is running at 5,000 RPM and it's producing 14.5 volts, that won't come to my fish finder. in the same manner as when I crank it and it drops down to 11 volts or something, the DC-DC converter will continue to produce 12.3 volts. It does not change. It will also, if your battery is very low and weak, it might be down at 12 volts or 11.5 or something like that, it will continue pulling your battery until it's absolutely dead. So you need to be aware of that. But yes, I think it's a fantastic thing, just providing that clean energy to your marine electronics. In cases where you've got a big boat and you've got a separate house battery with a charging control system, you're not going to get those same fluctuations in voltage because you'll have independent batteries to start your motor, and then the charge controllers will take care of making sure that your house battery is providing nice healthy charge to your or nice healthy voltage supply to your marine electronics. So yeah, I thought I'd just run that by you. Also, just a point, I do have the power supply from my one and only battery. I've got a 25 amp fuse at the battery supplying into the DC-DC converter. So the power supply into the unit is protected at source. So yeah, hope that's it might shed some light on some issues you might be having or something you want to improve on your boat. Cool.